Hello and welcome. My name is Robert and I'm going to be presenting your maths lesson today. It's great to be here. It's great to be able to do this. It's great to be able to bring the learning to you. And yeah, in today's lesson we're going to be speaking about analytical geometry. We're going to be moving a little bit forward. In the previous lessons we've spoken about distance and we've spoken about midpoint, and today we're going to be talking about gradients and we're going to be talking about lines. So let's jump straight into it. I've shown the content map again. It's fairly similar to what we've seen before. We can see here, oh sorry, let me just choose my pen. We can see here that I've included lines, and that's what we're going to be talking about today, which is more that was on the content map, but we're going to be starting with the gradient. Now, we've spoken about the gradient when we've done functions, we've drawn straight lines, we've done parabolas, and we've spoken about average gradients. But I just want to go back there. I want to make sure that we've got those concepts, because that's going to be critical in analytical geometry. So, what is gradient? The gradient of a line is determined by the ratio of the vertical change to the horizontal change. Now, that sounds super fancy and it's quite complicated, but all that gradient is it's a fancy word for the steepness of a line. How steep is a line? How flat is a line? And so if we look at this next slide and the image on it, we can see here I've got 4 lines. I've got OT, OS, OR, and OQ. And here we can clearly see that OT is the steepest line and OQ is the least steep line. All right. But when we're talking about gradient, and this is the thing here, is if I were to draw in, and let me do this in blue, if I were to draw in 5 more lines, suddenly I'm going to start running out of English words to describe what the steepness is. Like this is the most steepest. And this is a little bit less steep. And this is the least steepest. And to actually describe each of these 9 lines with English words, it's going to be difficult and it's not going to be exact. And I'm not going to be able to apply it to the next image where I've got a line that is steeper than the most steepest line. And so what we're going to be doing is we're going to be, instead of assigning words to the steepness of a line, we're going to be assigning values. We're going to give a number to how steep a line is. Now, this number we're going to do by using this formula, all right? Exactly like we had formula for the distance and a formula for the midpoint, we've got a formula for the gradient. And again, please make sure that when you use this formula, you take it from the formula sheet. It's so easy to make a careless mistake and add instead of subtract if I try to remember that formula. So get the formula from the formula sheet and let's make sure that we get these questions right. All right, so the formula for the steepness of a graph, the gradient of a graph that'll give the number, which is the steepness of the graph, is this. If I've got 2 points, O and S, so if I were working out the steepness of this line, what I would do is I would take the y value of the second point and subtract the y value of the first point. And then I would take all of that and I would divide by the x value of the second point minus the x value of the first point. And that will give me a number that would describe the steepness of a graph. Yeah, awesome. So let's jump into some examples. Here we can see they ask us to calculate the gradient between A and between B. And again, what is the gradient? They're just actually asking us, what is the steepness of this line? What we're going to be doing is we're going to be using the formula. So here I've got the same line and the same points. I've just put the sketch in the corner here so that I've got a little bit more space to work. And the gradient, which also, just as an insert, we generally going to refer to as M. I don't know why, but M it is. And M is going to be the gradient. And what am I going to do? I'm going to take the y value of the second point, and I'm going to subtract the y value of the first point. And again, we discussed this when we were doing distance in the first lesson, but it's so crucial that when I subtract a negative, that I put that in brackets. It's too easy to, by mistake, do 7 minus 3. It's not 7 minus 3. It's 7 minus negative 3, and that's important because that becomes a positive. That becomes 7 plus 3 and not 7 minus 3. And so let's be careful that we get that right. What am I going to divide it by? I'm going to divide it by the x value of the second point, and I'm going to subtract the x value of the first point. Again, I'm going to put it in brackets there. And let's go to our calculator. Let's do it on our calculator. I'm going to go 7 minus 3, and at the bottom I'm going to go 4 minus 1, and what we get is 2. And so this gradient has got a gradient of 2. Now if we go back to the previous sketch, and I just want to quickly talk about this, is here we had 4 lines, each with different steepnesses, and this line had a steepness of 2. If we go to a line that is steeper than it, it's going to have a gradient that is more, so 2.5 or 3 or 4. If we go to a line that is less steep, it's going to have a gradient that is smaller. So that's going to be 1.5, and this could be a gradient of 1. And so steeper lines will have bigger values, flatter lines will have smaller values, and all those lines that are going up will have positive values, and all those lines going down, you can see these are going in a direction that is downwards, will have negative values. And so this gradient could be equal to -2, and this gradient could be equal to -3. Now, if we go back to the next example, so the next example, exactly like we did with distance and with the midpoint, we started with values, and then we moved into an algebraic space. And that's what we're doing here, is we're going to be working out the gradient of algebraic points. And so here they ask us to calculate the gradient between C and D. Nothing changes here. I'm going to do exactly what we did. It looks a little bit strange because there's x and y's, but it's not. It's exactly what we've done, and we're going to use exactly the same formula. So the formula was m for the gradient is going to be equal to the y value of the second one, which is y plus 4, and I'm going to subtract the y value of the first one, which is y. I'm going to divide that by the x value, and let me do this in red so that we can see what's happening here. I'm going to take the x value of the second point, and I'm going to subtract the x value of the first point. But again, and what's crucial here is that when I subtract two things, when I subtract a multi kind of piece or something, I always have to do that in brackets, because I'm not only subtracting the x, I'm also subtracting the -3, and so I have to put that in brackets. Now, all that remains for me to do is I'm just going to simplify this a little bit, and so I'm going to get y plus 4 minus y, and here I'm going to see the y's will cancel out, and I'm just going to be left with 4 at the top, and at the bottom I'm going to have x. And what did we decide earlier is that in front of this bracket is a -1. And so I'm going to go -1 times by x is -x, and -1 times by 3 is +3. The x's will cancel out, and the gradient, what's left at the top is a 4, and what's left at the bottom is a 3. And so my gradient of these 2 points is 4/3, and it doesn't matter that it's not a nice number. That's perfect. Great. So here we're going to go to an ad break. I will see you guys soon. Welcome back. In the previous part, we just spoke about the gradients, and now what we're going to be doing is we're going to be talking about the applications of gradient. How does that look in analytical geometry, and how are we going to use that going forward. So the first thing that we're going to be talking about is points on a straight line. Now, the definition of a straight line is a set of points with a constant gradient between any of those 2 points. So here what I've done is I've drawn a line. Here you can see A and B and C. And if I ask you guys, does that look like a straight line? Is it a straight line? Well, obviously it's not. It definitely isn't a straight line. But what do we see here? That this line, oh, and sorry, let me go back here. This line is less steep than this line. This gradient is not equal to this gradient. And so because the steepness is not the same, this is not a straight line. Whereas if I look at this line here, I've got 3 points here, A and B and C. And does everybody see that the gradient M between the first 2 points and the gradient M between the second 2 points, the steepness doesn't change. It's exactly the same steepness. And because the steepness doesn't change, it's a straight line. And so if they give me 3 points and they ask, is this a straight line? All I need to do is I need to look at the steepness on each of these sections and ask, is it the same? Because if it is the same, then it is a straight line. If it's not the same, it's not a straight line. And so let's do an example of that. Here they ask us, do the following points lie on a straight line? So I've got 3 points here. And so all I'm going to do is I'm going to work out the gradient. Oh, sorry, that M was not nice. There were 3 loops in that. If I work out the gradient of AB, and I work out the gradient of CD, the question is, are they the same? Sorry, not of CD, of the second 2 points, which is BC. So if I work out the gradient of the first 2 points, that gradient, and I work out the gradient of the second 2 points, BC, if they are the same, it's a straight line. If they're not, then it's not a straight line. And so very simply, let's go do that. Let me just erase here so I've got more space. And what do we do here? We said I'm going to take the y value and subtract the y value. I'm going to take the x value and subtract the x value. What I've got at the top, minus 3 minus 1 is minus 4. And at the bottom, 5 minus 1 is positive 4. And the gradient of the first 2 is minus 1. What did we decide? If it was positive, it was going up. If it was negative, it was going down. So this is a line going down. Now, let's look at the gradient of the second one. I'm going to go the y value of the second point minus the y value of the first point. So it's going to be minus 1 minus 3. Again, crucial. If I'm subtracting a negative value, I'm going to put that in brackets. And then I'm going to go the x value minus the x value, 3 minus 5. And what I get here, minus 1 minus 3. Let's actually do that on our calculators, make sure that we get that right. So let's choose this. I'm going to go minus 1 minus 3. And at the bottom, I'm going to go 3 minus 5. And what do I get? I get a gradient that is also equal to minus 1. And so the gradient, the steepness on the first section, was the same steepness as the second section, and therefore I can definitely say this is a straight line. Okay, so if we do that, if they ask us, do the following points lie on a straight line, all right, the first 2 points are the same, and so the gradient of the first 2 points is minus 1, all right. But if I look at the gradient of the next 2 points, let's calculate that. And what did we say? It was going to be the y value minus the y value. So it's going to be 0 minus 3 in brackets to make sure that I subtract the negative. And then I'm going to go the x value minus the x value, 3 minus 5. Let's go back to our calculator, put it in. I'm just going to navigate. I'm going to navigate to the top here and I'm just going to make that a 0 at the top. So 0 minus negative 3 over 3 minus 5. And what do I get? Negative 3 over 2. What is that? That's negative 1.5. I'm going to leave it as negative 3 over 2. But does everybody see that the gradient between A and B is not equal to the gradient between B and C? And so therefore, A, B, and C do not lie on a straight line. Awesome. So we can always see if 2 points lie, or 3 points lie on a straight line by checking the gradients and seeing, is the steepness of different sections the same? That's the first application that we're going to be talking about with gradients in analytical geometry. Awesome. So we saw that it didn't lie on a straight line. Now, the next part that we're going to be doing is exactly like with the gradient. We worked out the gradient. Now we're going to be working backwards. So the next question says that find A if these 3 points lie on one straight line. So now we're starting with the end point and we're working backwards. So they are telling us that these 3 points lie on a straight line. So what is that saying? What that's telling me is that the gradient between these two, the gradient of AB, is equal to the gradient of BC. So they are telling me it's on a straight line, which means the gradients are the same. And so that's my starting point. That's where we're going to start. And so I'm going to somehow try set up an equation to calculate what A is, but I'm going to be starting with the fact that the gradients must be equal. So let's do that. The gradient of AB is equal to the gradient of BC. And so let's go calculate the gradients of AB. What did we say? It was going to be the y value minus the y value. So I'm going to go minus 3 minus A over the x value minus the x value, 5 minus 1. So the gradient of the first section must be equal to the gradient of the second section, which is going to be minus 1 minus, and again, when I subtract a negative number, I'm always going to put that in brackets. So it's going to be minus 1 minus minus 3 over 3 minus 5. Now, we're cheating a little bit because these are the same values that we had in the previous question. And so I know what this answer here is. That answer there is equal to minus 1. And on this side, I've got minus 3 minus A over 5 minus 1, which I know is equal to 4. Oh, sorry. I don't know what's happening with my eraser here. So let's just go back to that slide. Cool. Let's choose the eraser. All right, so we had 5 minus 1, which is equal to 4. And now all I need to do is I need to isolate A. So I'm going to multiply both sides by 4, because then the 4s will cancel out, and I'm left with minus 3 minus A is equal to negative 4. I'm going to add 3 on both sides, or take the minus 3 to the other side, which will give me minus A is equal to minus 1. And then all I need to do is get A alone. Again, they didn't ask me to solve for negative A, they asked me to solve for A. How do I get it alone? Well, in front of A, when we talk about minus A, we're actually talking about minus 1A. And so if it was a 2A, how would I get rid of the 2? I would divide by 2. And so if it's a minus 1A, how do I get rid of that minus 1? Well, I divide by minus 1 on both sides, and I'm going to end with, let me continue here, A is equal to negative 1 divided by negative 1 is positive 1. And so I know that A is equal to 1, which we actually knew was the answer because this is the same question that we did earlier. But again, so what can we do? We can see if 3 points lie on a straight line, or what we can do is we can say they do lie on a straight line, solve for something by setting up an equation. That was the first application of gradient within analytical geometry. The second aspect of gradient that we're going to be looking at is parallel lines. Now, when we look at parallel lines, two lines that run parallel are always going to be the same distance apart and have equal gradients. Now, that is the crucial part. Parallel lines have got equal gradients. Why? Because they're equally steep. They've got the same steepness, and so they're going to have the same gradients. And so here they say, and we're going to jump straight into the question, it says, show that the line AB is parallel to the function y equals 2x minus 2. Now, from functions, we know that the coefficient of x is the gradient. And so I know that the gradient of this line is equal to 2. If the first line has got a gradient of 2, then those lines must be parallel. They have the same steepness. And so let's work out the gradients of the line AB. If I do that, I'm going to go y value minus y value. So I'm going to go 6 minus 2. And here I'm going to go 2 minus 0, x value minus x value. And what do I end up with? I end up with 4 divided by 2, which I know is equal to 2. And so this gradient is equal to 2. What did we say about the first line? Well, the first line also has a gradient of 2. Their steepnesses are the same. They must be parallel. Awesome. So the third aspect that we're going to be talking about with regards to gradient is perpendicular lines. Now, perpendicular lines, we know, are two lines that intersect at 90 degrees. They intersect at right angles. But what we discussed in functions and what's important is that the product of their gradients is equal to -1. So if I take the gradient of the first one and multiply it by the second one, I'm going to get an answer of -1. Okay, so we're going to jump straight into the question like we did with the parallel lines, and they tell us that the first line, AB, is perpendicular to CD. So they're telling us that these two lines are perpendicular. What does that mean? That the product is equal to -1. So if I multiply the gradients, it's equal to -1. And they want us to find y. Now, we've done questions like this. This question is asking us to set up a gradient. So if I take the gradient of the first one and multiply it by the gradient of the second one, I'm going to get an answer of -1. And so that's what we're going to do here is I'm going to take the gradient here. I'm going to go 6 minus -2. I'm going to divide that by the x value minus the x value. So it's going to be -2 minus 6. And I'm going to take the first gradient and I'm going to multiply it by the gradient of the second one, CD, which is going to be the y value minus the y value, y minus 3, divided by x minus x, 7 minus 4. And this gradient, or this answer, must be equal to -1. What I've done here is I've set up an equation, and what I can do is I can go and isolate what y is. Now, I'm not going to finish this question. Write that question down for me, solve that equation for me, and you'll see that these two lines are perpendicular. Welcome back. So in the previous part, we spoke about the gradients and the applications. So parallel lines, perpendicular lines, and lines on and points on a straight line. And so what we're going to be doing now is we're going to actually be talking about lines and the equation of lines and just recap that a little bit because that's incredibly important. So we're going to be talking about lines. Let's get into it. And we're going to be talking about the equation of a line. Now, what we're going to be doing is we're going to be talking about the two things that describe a line. What makes lines different to other lines? So the first thing that makes a line different to another line is the steepness. So here we can see that ST is steeper than RQ. They're not the same line because they don't have the same steepness, right? And also, if I continue looking at steepness, this line RT is going up. This line has got a positive gradient. This line is going down. These are not the same lines. Why? Because the gradient is different. The second thing that describes a straight line is the positioning. So here I can see I've got two lines, ST and RQ. It looks like these lines are parallel, and so it's not the steepness that makes them different, but rather the positioning. Here I can see that ST is higher than RQ, and when we talk about positioning, what we're going to be talking about is the y-intercept. And so the y-intercept of RQ is lower down than the y-intercept of ST. If they were the same, they would be the same line. And so the two things that describe a line are the gradients, which is M, and the y-cut, which is C. So we've discussed this when we did functions. Our standard form is always going to look something like this: mx plus c, where m is the gradient and c is the y-cut. So here I've asked you guys to calculate the equation of this line. And so whenever we start a question like this, we always start by writing down the formula. You always start by writing down mx plus c, because this tells me, this helps me know what I must find. I must find the gradient, firstly, and I must find the y-cut. Now, does everybody see that automatically, by inspection, I know what the y-cut is? All right? They've told me what the y-cut is. They've told me that the y-cut is equal to 2. So I'm halfway there. All I now need to do is find the gradient. All right? What do I need for the gradient? Well, I know that the formula is y2 minus y1 over x2 minus x1. So I need 2 points. And I've only got 1 point. But isn't this also a point? They haven't told me what the x value is, but I know what the x value is. The x value is 0, and the y value is 2. And so I've got 2 points, and I can go and calculate the gradient using those 2 points. So let's jump straight into the gradient formula. What am I going to do? I'm going to go y minus y. So I'm going to go the y value of the second one minus the y value of the first one, 6 minus 2. Then I'm going to go the x value of the second one minus the x value of the first one. So it's going to be 4 minus 0. And what I'm going to end up with is 6 minus 2 is 4, 4 minus 0 is 4, and I know my gradient is equal to 1. So what have I done? I know what the gradient is, m is equal to 1, and I know what the y-cut is, c is equal to 2, and so now I have my line. Y equals, what is m? Well, m is 1 multiplied by x plus 2. That there is the equation of my line. All I needed to do was find the gradient and the y-cut. So let's move on to the next question. In this question, it says find the equation of the given line. So it's exactly the same question as the previous question. But what we see here, what makes this question different, is they haven't told me what the y-cut is. And so we're going to have to calculate that otherwise. But first, before we start any question, is we always start by writing down y equals mx plus c. Why? Because it helps us know what we must find. I must find m and I must find c. Now, here, I can go calculate m. How am I going to calculate m? Well, I'm going to use my gradient formula, and I'm going to go y minus y. So I'm going to go 7 minus 1, and I'm going to go x minus x. I'm going to go 3 minus 6. Again, when I subtract something that's negative, I do that in brackets. And what I end up with at the top is 6. At the bottom, I'm going to get 3 minus becomes positive, so it's going to be 3 plus 6, which is 9. And so I know that my gradient is 2 over 3. And so I've gone and found the first part of my equation. I can't do this part by inspection, all right? So we're going to have to do this a little bit differently. But let's go back to what I know so far. I know that's my equation. Y equals 2 over 3x plus c. I don't know what the y cut is, but I definitely know what the gradient is. But also what I know more than this is I know that if I put in 3, the whole idea about a function, and let me erase that up top there because it's a little bit messy, but I know the whole point about a function is that if I put in 3, I must get out 7. That's the whole point about a function, is its input and output. And similarly, if I put in minus 6, I must get out 1. And so if I put 3 in here, if c is equal to 100, the answer is not going to be equal to 7. And so what I can do is I can put in 3. So let's do that. And let me choose a different color here. I'm going to put 3 into x. I'm going to get out 7. And now the question is, what must c be so that this equation is true? I've set up an equation, and now I can just solve for c. So let's do that. Here I can see the 3's cancel out. All I'm left with is 7 equals 2 plus c. If I subtract 2 on both sides, I'm going to get that c is equal to 5. Awesome. And so I've solved for my gradient, I've solved for my y cut, and if I finish this question, y is equal to 2 over 3x plus 5. My y cut, which I didn't know, is equal to 5. Awesome. What we're going to be doing now is we're going to be talking about perpendicular and parallel lines. Okay, great. So we're going to be going to an ad break, and I'll see you guys soon. Welcome back. So we're going to continue talking about lines, and we're going to continue finding the equations of lines. But what we're going to be doing is we're going to be using the perpendicular and parallel properties to find the gradient so that we can go find the equation of a line. So let's jump into the first question. The first question says, find the equation of line ST. So I want to go find the equation of this line. It's going to be something y equals 2x plus 7 or something. So they want us to find the equation of that. And the information that they include there is that it's going to be parallel to line RQ. So what did we decide? That parallel lines have got the same gradient. So that's what I'm going to remember, is that parallel lines have got the same gradient. And I need to find the equation of line ST. I've put the sketch again in the corner so that I've just got a little bit more space to work, and let's jump straight into this. So the first thing that we always decided is that I'm going to start by writing down my formula. And I'm doing that because now I know what to find. I need to find firstly m, I need to find the gradient of this line, and secondly I need to find the y cut of this line. Now, the y cut I can see by inspection, and let me make my pen blue so that we can see nicely. But does everybody see that there? That's the y cut of ST. C is equal to 3. Awesome. Now all I need to find is the gradient. Now, in previous questions, what we did is we found the gradient by calculating the gradient using 2 points in the gradient formula. But here, on line ST, I don't have 2 points. And so I can't go and use the gradient formula to find the gradient. All right? But the extra piece of information that they told me is that line ST is parallel to line RQ. So if I can find the gradient of RQ, then the gradient of ST must be exactly the same. And so let's look at line RQ. All right, RQ has got the formula 2x minus 3, and so that 3 is the y cut. That doesn't help me though. What I wanted to know, what is the gradient? But what is that 2 there? That 2, the number that I'm multiplying x by, is the gradient. And so I know that the gradient of this line RQ is equal to 2. And so therefore the gradient of line ST is also equal to 2 because those lines are parallel. And so this graph has got the equation y equals 2x plus 3. Done. All right, so that was quite easy because I could do that all by inspection. I could see the y-cut, I could see the gradient, and so I could find that quite easily. All right, let's look at the next question though. The next question, they say, find the equation of line ST, all right, which is parallel to line RQ. Okay, so they've told me it's still parallel to RQ, and RQ still has the equation 2x minus 3, but if everybody sees here, the difference in this question is that they haven't given me the y-cut, all right? So when I start this question, I'm always going to start by writing down y equals mx plus c. Why? So that I know where I'm going, so I know what I need to find, all right? C, what does c equal to? Well, I can't do that by inspection. I can't see it, and so yeah, we'll get to that when we move on, but I'm going to have to somehow work that out. But this line is parallel to this line, and if this line's gradient, exactly like in the previous question, is 2, then the gradient of ST must also be equal to 2. And so I know the gradient is equal to 2. So I'm halfway there. I found M, and now all I need to do is I need to find C. Now, this is exactly like the question we did earlier, where I had the gradient, but I couldn't read the y-cut off the graph, the y-intercept. And so what we had to do is we somehow have to go find the y-intercept. Now, the only other piece of information that they've given me, and let me erase some of this so that it's not so full, but the only other piece of information that they've given me is that there's a point on this line -1 and 2. And this is the critical part. What do I know about functions? Functions are always input-output. So if I put -1 in, I must get out 2. That's the whole point about a function, right? So if I take exactly the same graph or the same function and I put in -1 into x, I must get out 2. Right? That, again, that's the whole point of functions. Input, output. All right? So does everybody see? This is really nice because what I've got here is I've got an equation where all I need to do is I need to go and isolate c. So let's do that. 2 times -1 is -2 plus c. All I need to do is get c alone. And so I'm going to add 2 on both sides. And when I do that, I get c is equal to 4. Wonderful. So now I've found the gradient. The gradient is equal to 2, so it's going to be 2 times x. I've found the y-cut. The y-cut is equal to 4. Excellent. And so there is the equation of my graph. One thing that I always want to do, and what's really nice about functions, you can always kind of decide, am I on the right track or not? So the gradient that I ended up with was 2. And what do we know? A positive gradient means that my graph is going up. Is my graph going up? Yes, it is. And so it feels right. The second part is I've gone and calculated the y-cut as 4. And so they're telling me that that is 4. Does that look right? Well, that y value there is equal to 2. And so the y-cut must be a little bit more than 2, not much more. So if I got 100, it would be a problem. But if I got something less than 2, it would also be a problem. So I'm not sure if 4 is indeed correct, but I know that it's kind of in the right ballpark. So if you've made a careless mistake, often that value won't look right or feel right, and so then you can go and fix it. Okay, so the next question we're going to be talking about is with perpendicular lines. And this question says, find the equation of line ST. So they want us to find the equation of this blue line, which is perpendicular to RQ. All right. Yeah, all right. So let's jump into it. Always what I'm going to do is I'm going to start, and I've said this multiple times, and it might get a little bit irritating, but I'm going to say this over and over because I want this to be just part of what you do. Whenever they ask a question like this, we always start by writing down y equals mx plus c, all right? All I need to do is find m, and I need to find c. In this case, c is nice and easy. By inspection, I can see that the y cut is equal to 3. All that remains is I must find the gradient of st. Now, this is a little bit more challenging because, again, how did we find the gradients? Previously, using 2 points in the gradient form. Now, what have I got? I've only got 1 point, and that's it. So I can't use the gradient formula. But exactly like we did with the parallel lines, I'm going to find the gradient of RQ, and somehow I'm going to find then the gradient of ST. And so let's do that. I know that the gradient of RQ is equal to 2. Why? This is the same line that we were working with earlier, but again, the number that I'm multiplying x by is equal to 2. And so, oh, sorry, let me move that gradient is in the wrong place. The gradient of the line going up, RQ, has got a gradient of 2. What is the gradient of the line going down? Well, what I do know about these lines is that because they're perpendicular, the product of their gradients must be equal to -1. Now, what does that mean? It means that if I multiply them, the answer must be equal to -1. All right. Now I'm going to teach you a little bit of a trick here. This is what I always like to do, is I know that the gradient of RQ is equal to 2, but what I'm going to do here, and I'm going to do this in red, and I want you guys to do this. If you're following, write this down for me because this is really important. I want you guys to write that as a fraction, 2/1. Now, what I'm going to be multiplying by is something so that the answer is equal to -1. Now, the first thing here, which is important, is, and let me just erase this a little bit so I've got more space. The first thing that's important is the only way that I get something negative is if I go a positive times a negative or a negative times a positive. And so how do I find the gradient of the line that's perpendicular? Well, it's always going to be the different sign. So if the sign of the line, one line is positive, the other sign must be negative. And so I know that the sign of my gradient of ST must be negative. First of all, because it's going down, but also because the product needs to be -1. And then how do I get a negative product? Well, I want the 2 to cancel out, and so I'm going to put a 2 there. And I want the 1 to cancel out, so I'm going to put a 1 there. And what would happen is I would cancel out the 2s, I would cancel out the 1s, and my answer would be equal to -1. And so if they ever ask you to find the gradient of a line that's perpendicular, all you're going to do is flip it over and change the sign. Awesome. So now I have my second sign, the gradient of my second line, -1/2. What did I do? I flipped it over y so that the product would be 1, and then I changed the sign so the product would be -1. So flip it over, change the sign. I now have the gradient, I have the y cut, and so I can say that my line is going to be -1/2 x plus 3. That's the equation of my line. Excellent. So let's jump into the second question. This question is exactly like the question that we did earlier, where I had to find the gradient, but I couldn't see the y cut. I had to go calculate the y cut. All right? So same thing. They've given me RQ. I've still got the same equation for RQ, 2x minus 3. And I'm going to go find the equation of line ST. Now, I'm going to start by writing down the formula, y equals mx plus c. All right. in this case, again, what makes this question different is I can't by inspection see what the y-cut is, and so I'm going to have to work that out. But what did we say? I know that this gradient of RQ is 2. Okay, so if the gradient of RQ is 2, what did we say? We would always write that as a fraction, 2 over 1. Why? Because the other gradient is always just going to be, what do? I flip it over and change the sign. So I'm going to flip it over and change the sign. And so I know my graph is going to have the equation y equals minus a half x plus c. I don't know what c is, but what I'm going to do is I'm going to sub in a point and calculate what c is. Excellent. So here, again, what is the function input output? So if I put in minus 1 into x, I must get out 5 from y. So let's do that. I'm going to go minus a half times minus 1 plus c. I'm going to get 5 equals negative a half times negative 1 is positive a half plus c. And in this case, I'm going to subtract a half on both sides. 5 minus a half is 4 and a half. Excellent. So now I know what the gradient is, I know what the y-cut is, and I've finished my question. The equation of my graph is minus a half x plus 4,5. Awesome. So let's move to the last question. I'm not going to be able to finish this question, but I'm going to start it, and I'm going to ask you guys to finish it for me at home or wherever you are. And this point has got the gradient, but also what we're going to be doing is we're going to be including the midpoints. More and more the questions are going to be multidimensional, including all of the things that we've learned. So here they say find the equation of ST, which is the perpendicular bisector of this line. So I'm going to discuss this very quickly, but they haven't even drawn in ST. So what is perpendicular? Well, it must be a line that is at 90 degrees, but more than that is it's a bisector. It's a line that cuts my line in half. So if I can find the midpoint here, and I can find the gradient of this line, then this question is exactly the same as the question that we just did. And yes, like I said, I don't have time to finish that at here, so I'd like you to finish that at home, wherever you are. But it's been wonderful. Thank you for coming into this lesson, for learning, and until the next lesson, goodbye.